In this particular segment, we'll discuss vapor absorption chiller and its working principle. We have not discussed this topic earlier. This is a very fresh topic for us. We are going to know how it works. We are going to take help of the slides as well as some animation to make your concept very clear. First of all, let's check out his look. Vapor absorption chiller looks like this. There are actually two chambers. There is one chamber at the top and there is another chamber here at the bottom, and there are pipelines connected top chamber with the bottom chamber, and there are also some pipeline connecting from the chiller to outwards, like chilled water going out, coming in, or cooling water going out and coming in. Those sorts of pipelines are in here. Now, before we get into any technical details, let's look at some basic fundamentals. In vapor absorption chiller, we use lithium bromide and water. Water is used for as a refrigerant here, and lithium bromide is used as an absorbent here. Now, at 1 atmospheric pressure, water, the melting point of water is 0 degrees centigrade, and the boiling point is 100 degrees centigrade. However, when it comes to lithium bromide, if it is 100% pure, the melting point is 550 and boiling point is 1267 degree centigrade. However, when it comes to lithium bromide 40% solution, lithium bromide basically a hydrophilic substance. It can absorb water. So melting point is now negative 3.7 degrees centigrade and boiling point is 270 degrees centigrade. So basically, at atmospheric pressure, water and lithium bromide has different boiling point whenever we get it into liquid mix up from, like in a solution. And if you heat it up, as water has lower boiling point, it boils up and goes away. However, lithium bromide are at the pot, so it doesn't vaporize very fast like water does. Now also, let's look back at pressure versus boiling point of water, the relation between them. So boiling point of water at 1 atmospheric pressure is 100 degrees centigrade. Remember, if the pressure goes low, the boiling point goes low. So at 0.1 atmospheric pressure, the boiling point is only 44.24 degrees centigrade. However, at 0.01 atmospheric pressure, the boiling point is as low as 2.9 degrees centigrade. So these are the basic stuff that we need to learn to understand the working principle of vapor absorption chiller. Now, here is the circuit of vapor absorption chiller. It looks like this practically. And here is the total circuit. So firstly, let's have an open discussion on the circuit. And after that, we'll go one phase by phase, one phase to other phase like this. So let me zoom in for your convenience. Yeah. Okay. Remember, in vapor absorption chiller, we have two different chamber. One chamber it at higher pressure chamber, and the other chamber is lower pressure chamber. The chamber at the top is actually higher pressure chamber. The pressure inside is 1/10 of atmospheric pressure. But the pressure at lower pressure chamber is very low, is 1/100th of atmospheric pressure. So these two are the chamber. And if you see, there are two different types of pipelines connected here. Some pipeline they are connecting two chambers, higher pressure and lower pressure chamber, like this one, the black one, and the gray one, and the pink one. They are connecting top chamber with the bottom chamber. And there are pipeline which are external. They comes in and goes away, like this pipeline. This is pipeline actually coming from fan coil unit or air handling unit. Hot water coming in, chilled down, and going out. And there is a pipeline coming from cooling tower. Cool water is coming down and comparatively hot water is going out to the cooling tower here. And if we look deep inside, every chamber have two different segments. There are total four stages of making things happen here. The first one is generator, the second one is condenser, the third one is evaporator, and the fourth one is absorber. By now, we are well familiar with condenser and evaporator, and their we have learned this in Vapour compression cycle. Vapour absorption cycle, they do the same thing. Condenser do condensation and evaporator does evaporation. We also need to learn now generator and absorber, these things. So let's go step by step. Firstly, we need to learn how generator works, what happens here. Secondly, what happens in condenser. Thirdly, at evaporator, and finally at absorber. In each segment, after finishing lecture, I will take you to animation and help you to understand from animation, which will make your life easier. Okay. Now let's talk about generator first. This is the higher pressure chamber. In higher pressure chamber, the atmospheric pressure is 1/10 of atmospheric pressure. And there is a vacuum pump here. So whenever, let's say the very morning you come in the plant and you started the chiller, firstly the vacuum pump is going to make vacuum and will create a low pressure inside as low as 1/10 of atmospheric pressure. After it is done, vacuum pump will be stopped and the cycle will start. Firstly, the pink color solution here is actually a lithium bromide solution. So here, usually depending on the design criteria, we have 40% lithium bromide solution. Now this solution is sprayed upon a heat exchanger here. Now this heat exchanger is connected to some external source. Hot water comes in, let's say at 80 degree centigrade. Hot water can be generated by many sources. It can be generated by burning, let's say, any fuel, or burning waste, or from any green sources, or even from electricity or gas. Now hot water comes in here. Remember, pressure inside is 1/10 of atmospheric pressure. At this pressure, boiling point of water is only 42 degrees centigrade. So the solution here is lithium bromide and water. It falls upon this heat exchanger. The temperature of this heat exchanger is 80 degrees centigrade, which is fairly above the boiling point. And in this particular scenario, water boils up and evaporates. Remember, to make evaporation happens, we need latent heat. In this particular scenario, the source of latent heat is the hot surface or hot water running through this coil. As this hot water inside the coil is providing the latent heat, it cools down, and from higher enthalpy level, it goes into a lower enthalpy level. Let's say around 60 degrees centigrade is water out temperature. So after this generation, we have concentrated lithium bromide stored at the very bottom, and water evaporates and stays in here. Before going into the second stage, let me take you to a animation and help you to understand generation portion better. Okay. Okay, so here is the animation for you. Vapour absorption chiller. This one is the top chamber, and the other one is the bottom chamber. Okay, higher pressure chamber and lower pressure chamber. Now at the generation, what happens here? We are spraying lithium bromide solution. So lithium bromide and water mix, it's been sprayed here. And what water is passing through? And vaporization happens. So after this segment, we are going to get lithium bromide concentrated solution left at the bottom of this pan, and vapor inside the higher pressure chamber. Moving on, for now, after generation, inside the lower pressure chamber, pressure is supposed to go high because the vapor already filled out the whole area. Now we need to remove this vapor. And how to do so? We do by condensation. So the second stage is condenser. Through the condenser, comparatively cold air, water is passes through from cooling tower, and condensation happens. So whatever vapor generated in generation is being condensated and being stored in a pan in here. The second step, condenser. Now let me take you to the animation for a visual of condensation segment. So remember, at the very first stage, we had liquid lithium bromide and vapor. Now in the second step, water from the cooling tower is passing through the heat exchanger, and the vapor is coming in contact with this heat exchanger and getting condensation. Now this condensated liquid water will pass from high pressure chamber to low pressure chamber. And there is a tray here. The water will stay in this tray first, and this water is going to be sprayed again. Okay, we'll come back to this animation once again. Let's go back to the details here. So after condenser, we have evaporator. So what happened at the very first in the second stage, we have the condenser. Water is in here. Now this liquid water will come to this lower pressure chamber. The lower pressure chamber, the pressure is 1/100th of the atmospheric pressure. So when water will come to this particular chamber, remember here is the boiling point around 3 degrees centigrade. I think it's around 2.972. I take it to 3 degrees centigrade. Well, water will fall in here. Remember the water temperature was higher in condenser. Now when water will come and drop in here, what happens is that the temperature of water will fall down to 3 degrees centigrade, and some of the water will be vaporized. Not the whole water, but some of the water will vaporize because the sensible heat of the water was higher in condenser. When it comes suddenly to a chamber where the mm, uh, boiling point is 3 degrees centigrade, what happens in lower pressure? Suddenly, um, it becomes into 3 degrees centigrade. The water temperature goes down, and some of the water evaporizes. Now this water is getting sprayed on top of a heat exchanger. Now, in the building, there are fan coil unit, air handling unit, or fresh air unit. From this unit, hot water comes in and feed into evaporator. The usual temperature here is 12 degrees centigrade. Now this 12 degree centigrade water passes through the evaporator, and whenever we spray water on top of it, as the boiling point is only 3 degrees centigrade, the sprayed water boils up and evaporates. Remember, for evaporation, again, we are going to need the latent heat. The source of latent heat is from the water inside this condenser. And two things happens here. Firstly, the water which drips on this heat exchanger boils up and evaporates here. Evaporation happens. And secondly, temperature of the water falls down to 6 degrees centigrade. As this sensible heat is transferred into latent heat, so the water from higher enthalpy goes into lower enthalpy, and this is the target temperature, 6 degrees centigrade. This is going to be fed in fan coil unit and air handling unit heat exchanger, and will do cooling of the room. Now again, the temperature here is the pressure inside this evaporator is going to increase if the vapor are not being managed. So for now, the whole chamber is filled with vapor. And if the whole chamber is filled with vapor, it's going to increase the pressure inside the chamber. We need to remove it. To do so, remember at the generator, we have produced lithium bromide, concentrated lithium bromide. This concentrated lithium bromide are to be sprayed here. And as lithium bromide is highly hydrophilic substance, it's going to absorb the vapor and work as the absorbent, and it will turn into lithium bromide solution here. So in this manner, the vapor is going to be disappeared from this chamber. Okay, these are the total 4 steps. Step 1, lithium bromide generated. Step 2, vapor are condensated. Step 3, we have evaporation, like this water is going to evaporate. And finally, absorber, the water vapor is going to be absorbed. This process goes on, and as an outcome, we get cold water at the output here. And we are going to deliver it to fan coil unit and air handling unit. Anywhere there is cooling, if there is a cooling coil, we are going to deliver this, and we are going to get hot water from cooling coils. Okay, now let's go to the animation once again. No. Okay. Now water is being sprayed. This is step 3, evaporation. So water is being sprayed, and here we have hot water coming from fan coil unit or air handling unit. And as it is being sprayed, remember inside here in the lower pressure chamber, the pressure of lower pressure chamber is 0.001 atmospheric pressure. So boiling point here is around 3 degrees centigrade. So now we have vapor in here. So vaporization happens, evaporation happens. Okay. Now, at the very first stage, generation, we have generated lithium bromide. This concentrated form of lithium bromide now is going to be transferred, and it's going to work like an absorber. Okay. It passes through a heat exchanger to make sure it doesn't crystallize, as lithium bromide is prone to crystallization. Now, this lithium bromide is being sprayed in this chamber. Yeah. Okay. Lithium bromide is being sprayed. Now it is a highly hydrophilic substance. It is going to absorb vapor from this lower pressure chamber, and as it absorbs the vapor, we are going to get lithium bromide solution. This lithium bromide solution will be transferred back to the higher pressure chamber, and that's how the show runs. Okay, let me take you back to the slides again. It is not that difficult to understand, only maybe the concept is a bit different than vapor compression cycle. Let's go through this discussion one or two times. Will be very easy for you to understand. So remember, vapor absorption chiller is highly efficient. Now let me give you an example. For instance, if a 300 TR, if a 300 tons of chiller taken, what are the electrical component we have? We have two vacuum pumps. So two vacuum pumps will be individually 2 into around, let's say, 3 kilowatt, will be together 6 kilowatt. And there are two pumps here. The pumps are individually around 5 kilowatt. So 2 into 5 kilowatt will be 10 kilowatt. So 16 kilowatt is the electrical energy you need basically to run the whole 300 tier. Highly efficient, isn't it? However, the biggest challenge and also the beauty of having this chiller is the generation of hot water. Let's say at 80 degrees centigrade. So if you can generate hot water in a cheaper mean, you can run the whole show very, very efficiently. For instance, let's say if you have the availability of any waste, and the waste heat can be used to boil up the water at 80 degrees centigrade, and you can use the waste heat to run the chiller, will be very efficient. And sometimes, depending on the country, the oil is very cheap if you are living in the Middle East, and sometimes in places where gas is very cheap, natural gas, then you can run it in the gas. However, if you have this vapor absorption chiller, it is very, very efficient. It can bring down the electrical bill to very low. Just you see here, 16 kilowatt is running 300-ton chiller only. If you have a waste heat, and if you get freely 80 degrees centigrade of hot water, life is beautiful, isn't it? You can run the whole chiller very low, very low electrical bill will be there. So it'll be very low operational cost, low cost of production, higher profit margin, business run well. Usually vapor absorption chiller are mostly used in factories, industries. Okay, that's all about vapor absorption chiller. Very interesting topic. Go through them once more. If you have any issues, contact me. I'll be there for you to support it. Let's move forward with the next segment.